So once again, good morning, everyone. So today we will discuss the refraction further. In the last video, I have discussed about the two Snell's law, and the second law was that the refractive index of a medium is basically or the sine of angle I with sine of angle R will always comes a constant, which is the refractive index of second medium with respect to the first one. I would like to start from that only. See, if I'm considering this scenario, this one as medium 1 and this one as medium 2, and considering medium 1 as rarer and this one as denser. Now see, I'm saying that this yellow ray of light when will pass from this rarer medium to denser medium, making an angle I, which is angle of incidence, and angle R, angle of refraction, then according to Snell's second law, we will have a relation. That is, if I'm going to take the ratio of sine of angle I to the sine of angle R, we will receive a constant. That constant is basically the refractive index mu of medium 2 with respect to the first one. So moving further, I would like to tell you about that this refractive index could also be expressed in terms of speed of light. How? Because see, we know that basically the change in this change in this angle, that is refractive angle, if a ray goes from rarer to denser medium, it happens only because of the change in velocity of light due to the change in the medium. So we know that there is a formula for velocity, which is if I'm talking about wave, it is v is equal to f lambda where f is the frequency of that wave, and lambda is the corresponding wavelength. Though these quantities are uh, dependent on some cases, like frequency is a source dependent property, it doesn't change while changing the medium, but lambda, that is wavelength, it changes while there is a change in the medium, and correspondingly the velocity will also change. Because the velocity is getting changed while moving from one medium to another medium, so due to this change in velocity, this angle of refraction also changes. See, I am considering this as a denser medium and this one as rarer medium. So here you can see the ray of light is coming, and after refraction, it is going away from the normal. Okay, so all of this is happening due to the change in the velocity of light while changing the medium. So the refractive index is further defined in terms of velocity of light, which is, it has been said that basically refractive index is the ratio of speed of light in air or vacuum, and we know that it is c, whose which value is 3 into 10 to the power 8 meter per second, right? And next, we have to take the ratio of speed of light in air or vacuum to the speed of light in that particular medium, right? So this is the new definition for refractive index, which we can express in terms of speed of light in air or vacuum and to that medium. So from here we can obtain the absolute refractive index. See, this refractive index is also called absolute refractive index, absolute refractive index, absolute refractive index of that medium, because it is with respect to the air or vacuum only. I hope this is clear. Moving further, if I am going to move to the next topic, which is further discussion of this refractive index only. See, if I'm considering, let's say again, the two medium separated by a separation line, let's say this one. So again, there will be a ray of light, considering this ray of light like this. And after refraction, it will go something like this, considering that that one was a rarer medium and this one is a denser medium. And this is my normal. So you can clearly see there is a difference between the angles made by the incident ray, right? So let me write the angle I and angle R here. So this one is angle I, and this one is angle R. And I said that this one is rarer medium and this one as denser medium. And the absolute refractive index of this rarer medium is, let's say, mu1, and the refractive index of denser medium is mu2. Now, if I'll say that this ray of light is passing from rarer to denser medium, and we have to find out the refractive index of medium 2 with respect to 1, then by formula we will write mu 2 1 or 1 mu 2. This simply means that refractive index of medium 2 divided by refractive index of medium 1. Because we are having a relationship, that is mu is equals to, or absolute refractive index is equals to, nothing but c upon v, where c is the velocity of light in air or vacuum, and v is the velocity of light in that medium. So putting or replacing this value in this equation, we will have c upon v2 divided by c upon v1, right? And rearranging this equation, we will get, we will cancel out the c and we will get v1 upon v2. So from this solution, we can say that if we want to find out the refractive index of medium 2 with respect to medium 1, and if we have the knowledge of velocities in two different medias, we can simply calculate it by, sorry, we can simply calculate it by this formula. Okay. See, guys, those who are watching this video, I might be going too much slow or might be too much fast. So you have the option to speed up the video if you are feeling bored. Okay. Thank you. Now, moving to the next topic, if we have got to this formula, then we can write our formula in terms of wavelength if we want. How? See, because we know that the formula for velocity is nothing but f lambda. And if we are going to replace the v1 and v2 in the equation of refractive index, which was 1 mu 2, refractive index of medium 2 with respect to 1, which was v1 upon v2. See, in place of v1, we will simply write f lambda 1, right? And in place of v2, we will write f lambda 2. See, because the frequency will not change, it is a source-dependent property. So we will cancel out the frequency because it will remain same in both of the two media. So from here, after solving, we will say in terms of wavelength, we can say the refractive index of medium 2 is basically the wavelength in medium 1 upon wavelength in medium 2. I hope you all got my point, and this is the this is for this video only. For further, I will be continuing in the next video. Might be I will upload by today, or might be tomorrow. Okay, class. Thank you so much.